Hello everyone. In the beginning of the class, let us see new announcements. Okay, today we have many new announcements. Okay, so the first announcement is that April 6, 2022 class videos uploaded. Hello everyone. I have uploaded the class videos of April 6, 2022 to YouTube. Their URLs are this, and this. Best regards, Wei Zhen Liu. Okay, the next new announcement is old midterm exams uploaded. Hello everyone. I have uploaded old midterm exams to the eCourse2 website. The location and the file name are eCourse2 website. Multiple input, multiple output techniques for wireless communications. Course content, midterm exam, old midterm exams.zip. Best regards, Wei Zhen Liu. The next new announcement is we do not have classes this week. Hello everyone. According to the calendar of our school, April, I misspelled the word April. Okay, April 11th to 17th, 2022 is the midterm exam week. Therefore, we do not have classes this week. Best regards, Wei Zhen. Okay, the next new announcement is midterm exam uploaded. Hello everyone. I have uploaded the midterm exam to the eCourse2 website. The location and the file name are eCourse2 website. Multiple input, multiple output techniques for wireless communications. Course content, midterm exam 2022-0411B.pdf. Best regards, Wei Zhen. Okay, the next new announcement is Homework 1 solution has been uploaded. Hello everyone. I have uploaded the solution to Homework 1 to the eCourse2 website. The location and the file name are eCourse2 website. Multiple input, multiple output techniques for wireless communications. Course content, homework. Homework 1 solution 2022-0412.pdf. Best regards, Wei Zhen. Okay, the next new announcement is grades has been uploaded. Hello everyone. I have uploaded your grades of this course to the eCourse2 website, including attendance and homework 1. The location and the file name are eCourse2 website. Multiple input, multiple output techniques for wireless communications. Course content, grades. Grades 2022-0412 anonymous.xlsx. If you have any questions, please tell me. Thank you. Best regards, Wei Zhen. Okay, the next new announcement is about MIMO Homework 1. Dear everyone, I sent an email to each of you today morning. The title of the email is about MIMO Homework 1. If you do not receive this email, please let me know. Best regards, Wei Zhen. Okay, the next new announcement is this week is online teaching. Dear everyone, this week is online teaching. Best regards, Wei Zhen. Okay, the next new announcement is the slides of chapter 2 has been updated. Version 2022-0418. Hello everyone, I have uploaded the latest version of the slides of chapter 2 to the eCourse2 website. The location and the file name are eCourse2 website. Multiple input, multiple output techniques for wireless communications. Course content. Slides. Chapter 2, the MIMO capacity formula. Slides 2022-0418.pptx. Best regards, Wei Zhen. Okay, the next new announcement is the handout of chapter 2 has been updated. Version 2022-0418. Hello everyone, I have uploaded the latest version of the handout of chapter 2 to the eCourse2 website. The location and the file name are eCourse2 website. Multiple input, multiple output techniques for wireless communications. Course content. Handouts. Chapter 2. The MIMO capacity formula. Handout 2022-0418.pdf. Best regards, Wei Zhen. Okay. So next, before the class, let us go to the website YouTube. Okay, and let us see. Okay, let us see the video 2022-0406 part 2. Okay. So about 11 days ago, a user named Apple Pie, okay, leave a comment here. Okay, at the 16 minute and 30 second, okay, let us go to 6 minute and 30 second. Okay, here. Why does the column vector multiply the row vector become a scalar? Okay, here is a column vector and a row vector. And in the last class, I said after we multiply this column vector and this row vector, we will have a scalar. However, it is wrong. Okay, so I left a comment here. Sorry, it is wrong. I will correct this error in the next class. Okay, so everyone, please open this is the chapter 2, page 100, problem 1. Okay, here is the mistake. So now I will tell you the correct version of the solution. Okay, so this equation is wrong. Okay, delete. Okay, here is wrong. Let us delete it. And this equation is also wrong. Okay, let us delete it. Okay, so after multiplying these two vectors, okay, this column vector and this row vector, we will have a matrix. Okay, let us, okay, a bracket and a matrix here. Oh, sorry. Okay, here. So first, okay, let us see, we multiply this element and this element. So this element, okay, summation I is equal to 1 to nt, okay, where nt is the number of transmit antennas. And h1i, okay, do you remember what is h1i? Okay, let us open the slides of chapter 2. Okay, and search for the h1i. So h1i, okay, where is the h1i? Okay. Okay, h1i, okay, is in this matrix. Okay, so where hij is defined as the channel response between the j's transmit antenna and the i's receive antenna. Okay, so this is equal to h1i and times si. Then what is si? Okay, Sj is defined as the symbol transmitted from the j's transmit antenna. Okay, so then times z1. Okay, so we copy the term z1. Oh, sorry, z1 here. Okay, and what is z1? Okay, zi is defined as the noise as at the i's receive antenna. Okay, and dots. Okay, and for the last element of the first row, it should be equal to this term. Okay, here, and times znr here. Okay, like this. Okay, and this is dots, and this is d dots. Okay, and this is dots. And for the first element of the last row, it should be this element. Okay, times this element. Okay, so it is equal to summation I is equal to 1 to nt hnr I siz1. So n and nr is the number of receive antenna and dots. And for the last element of the last row, it should be this term times this term znr. Okay, so this is equal to summation I is equal to 1 to nt hnr I si znr. And in the next step, we can move the expectation into the matrix and take on each element of this matrix. And because the expectation is a linear operation, so the expectation can be taken into the summation. And because h1i to hnri are constants, so the expectation can only be taken on the term si times z1 to si times znr. Okay, so this equation becomes this equation. Okay, a bracket and a matrix. Okay, like this. And this term, okay, here. And we can move the expectation, okay, here. And with a big bracket here. And move the z1, term z1 into it. Oh, sorry, si should be also in the expectation. Okay, like this. So this term should be dots. Okay, and this term is the same. Expect for the expectation. Okay, move to here and take the big bracket and siznr. Okay, so si, okay, let me see. Okay, si and znr. Okay, here. Okay, and this term should be, okay, dots. And here is the diagonal dots. And here is also the vertical dots. Okay, finally in the last row, okay, the first element should be this. Okay, with an expectation here. Okay, here. And a big bracket here. And move the term si times z1 into the expectation. Okay, so this is equal to dots. And for the last element in the last row, okay, let us copy this element and paste here. And here there is also a expectation here. Okay, and a big bracket here. And si times znr, okay, should be here. Okay, like this. And let us align at the equality. Oh, okay, it do not align. Okay, it does not align. Okay, so okay, that is okay. So therefore, next in digital communications, it is reasonable to assume that transmitted symbols and noise terms are independent. Therefore, okay, this equation is not correct. So delete it. So therefore, the expectation of, okay, si times zj, okay, is equal to the expectation of si times the expectation of zj and is equal to 0. Okay, this is for j is equal to 1 to nr. Okay, like this. Okay, this should be NR. Okay. And where the last equality holds, oh sorry, we should delete the word holds, results from the fact that noise terms Zj, j is equal to 1 to nr, are 0 mean. Okay, therefore, the expectation of H times S times Z transpose is equal to a 0 matrix. Okay, and with the element, with the dimension. Okay, what is the dimension of this 0 matrix? Okay, we can see that there are nr rows and nr columns. So this should be nr. Okay, and by so times let me here. Okay, nr by nr. Okay, similarly we can prove that the expectation of V times S transpose times H transpose is also equal to a 0 matrix. Okay, so what is the dimension of this 0 matrix? Okay, we can see that Z is an nr by 1 vector, and S is a nt by 1 vector. So S transpose is an 1 by nt vector, and H is an nr by nt matrix. So H transpose is a nt by nr matrix. Okay, so after we multiplying these three vectors or matrix together, the dimension of the result will also be nr by nr. Okay, so we copy the 0 nr by nr here. Okay, so we have correct all the mistakes in the chapter 2, page 100, problem 1. Okay, do you have any questions? Okay, if you do not have any questions, let us go to the see the progress of the last class. Okay, in the last class we have taught to chapter 2, page 104, problem 2, solution, equation 1. Okay, let us see this problem. Okay, chapter 2, page 104, problem 2. Derive the fourth equality in equation 2.32. Okay, let us go to equation 2.32. Okay, here. And this is the 1, 2, 3, 4 equality. Okay, we are going to prove that this equality is correct. Okay, so let us go back to the blackboard. Because I do not have a blackboard now, I use the Microsoft Word instead. Okay, so solution. Okay, in matrix property 1.9.2g, we know that. Okay, let us go to matrix property 1.9.2g. Okay, this is the slides of the chapter 1 and the matrix property of section 1.9.2g. Okay, it is 25 minutes.